Have you ever tried to learn a new technical skill, like coding or database stuff, and you just hit a total wall? Like you see the words, you look at the examples, but it just doesn't click. If that sounds familiar, trust me, you are not alone. Today, we're going to dig into exactly why that happens and uncover a really powerful science-backed tool that can help you finally get your head around these super abstract subjects.
It's a feeling we've all had, right? Trying to understand how an operating system juggles a dozen different programs, or how a database organizes millions of pieces of information. It can feel like trying to grab smoke. So what's really going on here? Why do these topics feel so tough to crack at first?
And boom, there it is. That's our answer. The heart of the problem, as these researchers point out, is abstraction. See, unlike learning about, say, a car engine, where you can actually see the pistons and touch the belts, computer science concepts are, well, they're invisible. They're just ideas, interpretations of ones and zeros that we can't see or physically get our hands on. So all of this abstract, invisible stuff, it creates what I like to call the intimidation factor. It's this collection of hurdles that can make anyone, and I mean anyone, feel totally overwhelmed when they're just starting out.
Yeah, people usually run smack into these four walls. First, there's the complex syntax. It's like you're trying to learn a whole new language, and man, the grammar is strict. Then, you've got to master this abstract way of thinking, just understanding how all these invisible pieces of data connect. And a lot of the time, there's no real-world context, so you're left wondering why any of it even matters. Put it all together, it's just a recipe for serious information overload.
But here is the single most important thing to remember. If you've struggled with this stuff, it is not your fault. It's not a personal failing. You're not bad at tech. You're just up against a universal challenge that the material itself presents. But what if? What if there was a way to make all that abstract, invisible stuff concrete?
Well, that's where this idea of a cognitive bridge comes in. We need some kind of tool to connect the weird, unfamiliar world of tech to the solid, concrete world we already get. And the best part? Our brains are already totally wired to use it.
Now, I know this sounds a little academic, structure mapping theory, but the idea behind it is actually incredibly simple. It basically just means we learn new stuff by mapping it onto something we already know. We find a familiar pattern, let's call that our base, and we use it like a blueprint to build our understanding of the new unfamiliar idea, our target. And that bridge, that secret weapon we've been talking about, is the good old analogy. It's really just a way of saying, hey, this new, confusing thing is a lot like this old, familiar thing. By finding that similarity in the structure, we can translate these crazy, complex ideas into a language our brain already speaks perfectly. Okay, let's put this to the test. We're going to take one of the most abstract topics in all of computer science, how an operating system schedules processes, and we're going to map it onto a place most of us have been before, a hospital. All right, let's build this out piece by piece. So think of a running program, in tech terms, a process, as a patient. They need attention, right? The CPU, the brain of the computer, that's our doctor. They're the one who actually does the work, provides the treatment. And all the program's vital info, its process control block, is just like the patient's file. It's got all their history and current status. Makes sense so far, right? Now let's take it a step further into scheduling. All the programs that are ready to run are sitting in what's called the ready queue. What's that like? It's the hospital lobby, full of waiting patients. The short-term scheduler is the nurse, the one who's looking at everyone and deciding who gets to see the doctor next. And the long-term scheduler? That's kind of like the front desk manager, deciding who even gets an appointment to come into the lobby in the first place. And this is where the analogy really shines, with one of the absolute trickiest concepts, context switching. In a computer, that's when the CPU stops working on one program to handle another one. It's pure overhead. And our analogy makes this so clear. Imagine an emergency call interrupts the doctor. What happens? The nurse quickly jots down some notes in the current patient's file, sends them back to the lobby, and rushes in the emergency case. That time spent switching, that is context switching. And notice, in that moment, nobody is actually getting treated. Okay, so that was a killer verbal analogy. But what about a visual one? Let's switch gears to another notoriously complex topic, databases. How can we make their invisible structure something we can actually look at? First, let's set the scene with another quick analogy. Think of a database server as a giant warehouse building at a specific street address. The database management system, the DBMS, is the warehouse manager. They're the boss, they know where everything is, and they know how to get it. And SQL, that's the very specific, very particular language you have to use to give instructions to that manager. You can't just shout, you gotta speak their language. But even with that analogy, what's happening inside the warehouse is still kind of a mystery, a black box. For that, we need a blueprint. And in the database world, this visual blueprint has a name. It's called an Entity Relationship Diagram, or an ERD for short. It literally makes the whole structure visible. And you know what? Making one of these is actually way easier than it sounds. First, you just identify your entities. Those are the main nouns of your system, things like customer, product, or order. Next, you list out their attributes, all the little details you need to store, like a customer's name or a product's price. And finally, you just draw lines between them to map out the relationships. And just like that, you've got a clear visual map of your data. So we've seen verbal analogies, we've seen visual ones. They feel right, they seem helpful, but do they actually work? Oh yeah, let's look at the numbers, because they are pretty mind-blowing. Check this out. When actual computer science students were taught using that exact hospital analogy we just walked through, they were asked to rate how helpful it was. The average score? A 4.9 out of 5. Wow, that's basically a perfect score. And let's break that down, because this is wild. Out of 32 students, 29 of them strongly agreed that the analogy helped them understand. Not just agreed, strongly agreed. And get this, not a single person disagreed. Nobody was even neutral on it. This is just incredible proof of how a good analogy can flip that switch from confusion to clarity. The big takeaway here goes so far beyond just computer science. This isn't just a clever teaching trick, it is a fundamental learning superpower. By consciously looking for analogies, you can build a bridge from what you already know to absolutely anything you want to learn, no matter how abstract or intimidating it seems. So, think about your own journey. Is there something you've always wanted to learn? Whether it's quantum physics, economic theory, or just some new piece of software at work, the right analogy is out there, waiting to make it all click. The only real question left is, what complex topic are you going to unlock next?